Hey, I'm Mayank,
And I'm Abhijit.
and this is a joke generation using mass language infilling on automatically extracted templates. We are both from Triple IT Hyderabad, so let's get started. So I'll first talk about the background of this project and where we're actually coming from. So humor is a very important task for understanding humans. If we understand humor fully, if we understand humor properly, I think we're able to we can say that we fully understand human cognition as well as human language. So humor is a very important task. It's a big part of our daily life. It's a big part of society. But AI till now cannot generate jokes by like actually understanding them. Even humans, as far as joke generation goes, is something that we still rely largely on intuition. Joke generation is not something that we've been able to do easily, even as humans. So humor is a challenging task, and it is a task that encodes a lot of semantics and encodes a lot of pragmatics on how our language works. So we want to generate jokes using a new method based on how jokes function intuitively according to our own intuition, and we want to use the current state of the art in NLP to generate our jokes. And through this we want to understand jokes and we want to understand human language. So this is the background, this is our motivation for actually working on this project. So let's go on. Now there is existing literature on humor generation. Humor generation is somewhat of a like topic of interest in NLP. So previously in 2021, there was work which I was part of where uh, we first worked on extracting templates from jokes and then infilling them using Word. At that time, we used a heuristic formula based on human-tuned scores for pause tags, as in giving high scores to nouns and verbs and lesser to other parts of speech tags and word frequency. And depending on that, we extracted uh, the mask, the thing, the tokens that we need to mask, and then we infill them using Word, just vanilla Word. Now, this project is building upon that. We are going more towards fundamentals. We are using more ideas from semantics in NLP and using the current state to make jokes. There have been lots of other works. There's pun generation. Pun generation is something that has been explored a lot. There's also work on using GANs for pun generation. There have been joke generation using templates. So you take a well-defined template, something like X is to Y as A is to B, and then you try to fill them. So those there have been a large family of works based around taking a set structure and then making those kind of jokes. So something like that's what she said jokes. There have been generative models used for joke generation, so LSTM models, simply LSTM models, even new modern techniques like GPT. So understanding humor, we at the end of the day, the task that I think all of us are trying to do is understanding what is a joke, what makes something a joke, and what makes something not a joke. So one of the core theories of humor is the incorporated theory of humor, where we say that a joke arises out of the disharmony of concepts, where two concepts are from different places, and when our brain resolves this conflict, because these two concepts are going to be from different places in our head, when this is resolved, we find it funny. So this is the incorporated theory of humor. Now that is where our inspiration, like where we take inspiration from. So two jokes can have same structures, right? So we have a lot of bar jokes. We have a lot of jokes about like why did a chicken cross the road? A lot of jokes based on these ideas, but they differ in content. So there is a style of a joke and there's content of a joke, which are two separate things. Now, can we somehow figure out a way to like utilize this structure and generate novel content? So, for the purpose of this project, we make a distinction between style and content. Now, style is a template of the joke. It includes all the stop words, includes the whole structure of how the joke is formed, and content are the words with high semantic contribution that are what make a joke funny. So, we first separate the style and content, and we replace the contents with new words using word. Now, let's get to the methodology of our project.
Right. So, going into the methodology of the project, we will first briefly overview what we do as a whole to generate jokes from existing jokes, which is extracting some templates from the jokes using ideas coming from semantic similarity and identifying patterns in the part of speech tags. And this next part will be once we have these templates, we infill them using models that are specifically trained for doing this sort of infilling. So, most famous of these is the BERT transformer, which is a model that was trained on masked language modeling, meaning it it is trained on the task of predicting a missing word given surrounding context. This is ideal for our case because the templates that we'll be extracting from jokes will be of the form where certain words of the original joke or certain sections of the original joke are masked, and then we will need to fill in or predict what word comes over there. And on doing so, the hope is that we are able to generate a novel joke which is funny as well. So let us go into the content chunk identification process first. In this part, what we aim to do is identify chunks of words from the original joke which contribute significantly to the content of the joke. So, like Mank described in an earlier slide, the we have this separation of the joke between its content and its style. So the style, like as we mentioned before, refers to the overall presentation and the stop words specifically chosen to convey the joke, whereas the content refers to the specific keywords, the specific topics present in the joke. So first, we use a heuristic to extract these keywords or content words, chunks of content words from the joke, and then we rank them using an idea of semantic similarity or to identify which of these content chunks contribute most to the meaning of the joke. For this, we use embeddings obtained from sentence word and make comparisons using cosine scores. We will describe that in further detail before uh, we first describe the method by which we extract content chunks. So we apply regular expressions to the original jokes to extract chunks following any of the following patterns, as you can see on in the slide. These could be some combination of adverbs and adjectives, some combination of adjectives and nouns, maybe preceded by some determiners, or some combination of adverbs and verbs again preceded by some determiners. So this choice is largely heuristic based, where based on the but it is based on the idea that these are the structures that most often contribute to the meaning of the joke. These taking every pattern which falls into these structures aside, what we are left is mostly stop words or filler words. So these, if we are able to extract words falling within these patterns and rank them on the basis of how much they contribute to the overall meaning, we can get a good idea of where the content of the joke lies. So once these chunks of words following these patterns have been extracted using regular expressions, what we do is we calculate the embedding for the sentence using sentence bird. So sentence bird is a model which is similar to bird, except that it acts on whole sentences, and we can obtain embeddings for the sentence using this model. So and these embeddings exist in a semantic space where if some two embeddings are closer together, it means that the sentences which they came from are closer together in meaning. And similarly, if two embeddings are further apart, uh, it means that the sentences which they came from are further apart in meaning. The distances between these embeddings is calculated using the cosine similarity. So to identify or rather to determine the importance of each chunk in the semantic contribution to the overall joke, we compare the embedding obtained on passing the joke without that chunk through sentence word with the embedding obtained on passing the whole unedited joke through sentence word, and we see which the removal of which of these chunks leads to the greatest difference from the original embedding, and based on this we can rank these chunks on the basis of how much they contribute to the sentence. Mean more to in more detail, what we do is check to see which chunk, the removal of which chunk may shift the sentence embedding most away from the original sentence embedding, and that is what we determine to be the chunk which contributes most to the content of the joke. So once the chunks with the highest semantic contribution have been identified, we replace them with masks. So the mask here is simply a mask token which we use to replace those specific words. And once this is passed to the infilling model, the infilling model predicts what words should come in place of the mask, and this leads to the creation of the joke. So we experiment with two different strategies for masking. One is masking some top n% of content words from the sentence. So in this case, it could be masking, say, about top 50% of the content words from the sentence. And keep in mind that we have our content words ranked according to semantic contribution. Another strategy is to mask chunks contributing up to p% of the content. So when we extract our chunks from the original sentence, we also get a value indicating the difference between the um, sen- sentence embedding of the original sentence and the sentence embedding of the sentence minus that chunk. And it's the difference between these two gives us an idea of how much that chunk contributes to the overall content. So normalizing among the different chunks, we can get an idea of how much content there is in each chunk, and proceeding from the most contributing chunk to the least, we can take the chunks which contribute up to some p% of the total content and and mask those. So we observe that for higher values of n or p, meaning masking a higher percentage of words or masking a higher semantic contribution leads to templates with more masks, like we can see in the example. So uh, if we consider the case where we are masking top 30% of content words from the sentence, we it results in three masks. Whereas if we are masking the top 60% of words in the sentence, content words in the sentence, then it results in much more masks and gives us a template which is much more generic than than the one obtained for the case where we're masking 30% of the words. So, another improvement that we have done over the previous work is fine tuning our infilling model. So, in the previous work, the authors had done the infilling using just a pre-trained BERT model. So, BERT is a model that has been trained on very general data, and it the kind of infilling it does tends to be very generic as well, which may not necessarily result in humorous sentences being formed. What we do instead is we first fine tune our model, which in this case is a distill bird, which is a smaller version of bird, on a jokes data set. So to create this jokes data set, we compile together jokes from three different data sets, which mainly come from the r/jokes subreddit on Reddit and the short jokes data set. Since these data sets have overlapping sources, we first remove duplicates and we filter for length as we want to focus on shorter jokes. And we finally obtain a corpus of about 267,000 jokes, of which we use 80% for fine tuning our model. We use 10% as a development set for experimenting with different strategies for infilling, and further 10% we keep as a test set for conducting a human evaluation and just examining the effects of different choices of parameters. So uh, this is the kind of loss curve we obtain on training when we perform our fine tuning. Details have been given here, but Sorry for the interruption. So this slide gives details of the specific hyperparameters we use for training and the loss curve. As we see, for the duration of our training, the training and validation losses both go down, which show that our model has learned to adapt itself to the specific joke data set, which makes it a good candidate for infilling into our templates. So the reason why we use bird for or a similar model to bird for infilling is because it very well fits into our task description of infilling on templates. This is different from language models like GPT, which only are able to predict the next word given the previous context. So something like BERT is able to fill in templates by looking at both sides of the masked words. So this makes it an ideal choice for our use case.
So let's look at an example. This is the original joke. What is the directive? We're on a flight, plain clothes. Now we get these chunks. Now we get these generated masks. So now we have a template. And then we get a new joke. What does Santa wear on Friday? Plain clothes. It's not very funny, but it does attempt to make a joke. Santa and Friday are related, and it gets related to the same concept of plain clothes. So I would say it's at least an attempt at joke. So now let's analyze our results. So we'll just take a look at some examples. There's a lot of data we got, and many of our jokes were funny. Many of them are also not funny and garbage. So the input data can sometimes be not great, and that can lead to faulty masking and structure. Now, faulty masking can happen even with decent input data. Our masking is not perfect, but template generation definitely causes problem. If the template generation is bad, then the masking can somehow just be weird. Uh, in the second example, you can see that there's a well extracted template, and so it's a decent, like it's a decently new joke. So why do women smoke the weed to avoid being confused with alcohol? It does make a lot of semantic sense of what this is trying to get at. Now there are the model does try to fit in words that it just thinks is funny, so it will use sexual words or words like Hitler, Stalin. So if we look at the first joke where Buddha, sister, hot vendor, make me one with everything, we have the same thing where now it's just Hitler talking to Stalin. And now another thing that we saw was that, for example, why do you call a black man flying a plane a pilot? Now here the black man is just replaced with Mexican. So the joke is still maintained, the intuition is still there, but we still have a new joke. So we see that Bert is at some level similar to human intuition and trying to connect things to this type.
Now, to study whether the jokes generated by our method are able to pass for real jokes or not, we conducted a human evaluation, and in this evaluation, we presented our human evaluators randomly with a series of either human written jokes or generated jokes, and the task was to identify whether the joke is human written or machine generated, and the results are reported in the slide. What was most interesting to us that about 25% of the times, the evaluators would report a generated joke as a real joke, which suggests that our method is capable of generating, at least to a limited extent, jokes that could pass for jokes written by humans.
So limitations. Our template extraction is still very heuristic based. We want to understand style content separation better so that we can make better masking and generate better templates. Our masked and filling is also currently at some level heuristic based. It performs fairly well because BERT is great, but we do want to explore using some like a knowledge graph to make better jokes so the structure is well maintained. Um, we have multiple references. Thank you to all the people who have worked on this before, whose ideas we could utilize. And thank you to HRC for giving us the opportunity. Thank you.
Thank you.